afternoon, everybody. I think we're going to get started with the webinar right here. Just a little information about myself. My name is Tyler Trent. I am the application sales specialist for the new automated QueChERS instrument we have here, the AutoMate Q40. Housekeeping information. This will be recorded and available on our website within a week. If you have any questions about the presentation, please post them to the Q&A box, and they'll be addressed at the end of the webinar. About Teledyne Tekmar. Teledyne Tekmar is located in Mason, Ohio. It was established in 1975. Products and services that we offer are instrumentation for environmental and pharmaceutical laboratory sampling. We are ISO certified. Technology specialties are Persian trap, TFT, TN analyzers, and headspace. The topic today that we're going to be discussing a brief view of QueChERS, the uses in automation, the methods that go along with QueChERS, the new AutoMate Q40 that Teledyne Tekmar has designed, and a bit of experimental conditions, results, and discussion and questions for a new application note for Oat. QueChERS is an acronym for a technique used to check pesticide residues from food matrices, fruit, vegetables, and tissues. It has been expanded to many other matrices, as you can see throughout other application notes that have been published. QueChERS stands for Quick, Easy, Cheap, Effective, Rugged, and Safe. It's an extraction method that was developed in the 2000s that would help you to replace the Luke method. The first method was developed in 2003. It was an unbuffered method. From that unbuffered method, two extraction methods have been developed. One is AOAC 2007.01, and one is the EN 15662-2008. So it involves a homogenized, addition of extraction solvents, addition of spikes and standards, addition of extraction salts and buffers, staking, vortexing, centrifugation, decanting, a dispersive solid phase extraction cleanup or cleanup if not needed, preparation of the final extract to be analyzed by GC or LC. Right now, I'll walk you through the steps of QueChERS to give you a brief overview of what it is. What you want to do is the homogenization and sampling. The must be homogenized to increase the surface area available for extraction to ensure a representative sample. With the process, it will generate heat that can dry off some pesticides of interest, thus compromising the analysis. For this, most labs are doing a cryogenic or subambient conditions milling process. After the sample is milled and ice is supplemented off, typically 10-15 grams of the sample, homogenized sample, is transferred over into a 50 milliliter conical centrifuge tube. Rice samples such as flowers, dried fruits, spices, teas have water content less than 25%. The sample size might need to be reduced anywhere from 3.5 to 5 grams, and water might need to be added. Sample will swell, and it will give you your final sample. So if you have 5 grams of the sample, you want to add 10 mils of water to give you the total of 15 grams sample. Step is the addition of the extraction solvent. The extraction solvent is added to the centrifuge tube. The recommended extraction solvent is acetate nitrile, but acetate and acetone may be used also. Nitrile is recommended because it is more and easily separate from the water, since most of the food samples contain anywhere from 80 to 90% water, and this is very important for this application. In general, anywhere from 10 or 15 mils of extraction solvent is added to the centrifuge tube, depending on which method you're doing, if it's the EN or the AOAC. Step internal standard can be added to help monitor the extraction efficiency and aid in the quantification of the sample target analysis. And this is all where you can spike in your QC standards if you need to. To add the extraction solvent, the acetonitrile, you might want to hit it with a quick vortex or a quick shake. Optional, depends on which method you're running. With that quick vortex, you want to add your buffering and drying salts. Salts can be added to dry the sample by binding a significant fraction of water in the sample, thus promoting the portion of the organic layers. The two methods, the AC and the EN, slightly differ in the amounts of salts and buffers being used. The EN uses 6.5 grams of salt, while the AOAC full method uses 7.5 grams of salt. For 10 samples, magnesium sulfate is added roughly from 4 to 6 grams, such that it exceeds the saturation point. Sodium chloride is added 1 to 1.5 grams to control the polarity of the extraction solvent for the unbuffered method. But once we go over to the AOAC and the EN, we start buffering our salts. As you can see on this down here, we have different types of buffering salts. A citrate buffer is used for the EN, and the acetate buffer is used for the AOAC. After the salts have been added, the tubes are tapped and are shaken vigorously for 1 minute. Some pesticides, such as those that are strongly protonated at low pH, require control of the pH. Thus, we will need a buffer, the pH anywhere from 2 to 7 for the extraction. Salt types or techniques add internal solutions. Internal solutions at this step, just prior to centrifugation. You can do it at different points throughout the method, whichever one your lab says you can do it at, your SOP. This is shaken again for 30 seconds to a minute. So this is centrifuge for a minute. This is where we introduce our separation. The centrifuge to separate the organic layer from the sample layer. As you get in spot number 6, you insert the tube into your centrifuge, and over 7, you'll see the layers that are formed. At the very bottom, you'll get your salts and buffering. You'll have a water layer, just right of the salts. Then you'll have a food plug. Then on top of that food plug is your organic, which contains your pesticides of interest. From top layer, an hour of the organic layer is decanted off and transferred over to a 50 milliliter centrifuge tube by dSPE. Depending on which type of commodity you're running, you do not need to do this. Apples, cherries, and things like that may not need cleanup, such as and grains might require cleanup to help you clean up the matrix. One can the organic layer is added to the centrifuge with the SPE media. Salt tube is shaken for 30 seconds. As I said this before, this step allows for the removal of background compounds such as fats, proteins, chlorophyll, etc. prior to analysis. The dSPE media typically consists of primary, secondary amine, and magnesium sulfate. That's your most common. But go through and work commodities such as spinach with pigments. I want to add GCB, the graphitized carbon black, which will remove the pigmentation or chlorophyll from that sample. The thing with GCB is it attaches onto planar compounds, so you might need to add some toluene in there to help it release the planar compounds back into solution. Samples such as high fat, such as grains, oats, and things like that, might require C18 to help you remove the fatty acids and other things like that. After the SPE step is shaken, it also spun down. As you see here, we have a couple different examples of commodities that have cleaned up different ways. On the left, A is a strawberry sample. B up is the GCB added so to remove the pigments. C is a normal PSA cleanup, and you still have pigmentation in it. On the right, the milliliter centrifuge tube is a spinach. As you can see, you get a nice dark green supernatant. From that is transferred over to the dSPE tubes, number 2B, PSA and mag sulfate, and then remove any of the pigmentation. But once you add a little bit of GCB over to it, it will remove the pigmentation and clean up your sample for analysis. Once with the dSPE step, the organic layer is decanted off the top and placed over into your GC or LC sample vials, your 2 ml sample vials. That step depends on which type of analytical method you choose. Depending on your detection scheme, a 3 to 10 times concentration of the extract might be achieve necessary sensitivity. Samples require additional concentration prior to analysis of the organic layer is decanted off. This technique is called blowdown. Or if you're on a LC triple quad, you might just need to do a 1 to 10, 1 to 20 dilution of your final extract into your mobile phase A and shoot it on. You also preserve your analytes, depending on which method you want to do. If it's DN or AOAC, you can either add a 0.1% acetic acid or 5% formic acid solution to analyze for stability issues. There's analyte protectors out there. Then after you preserve it, your supernatant is then ready for your GC or LC if you choose to do this step. What we're really here for today is a system overview of the AutoMate Q40. Basically, Teledyne Tekmar has designed an automated extraction system with a 40 sample capability. It is designed to automate the steps of the AOAC and the E and the unbuffered method. The system is capable of method customization. So if you want to do a send and mix, you can do a send and mix. If you want to do a send to spin down or centrifuge, you can do that. System only handles 50 and 15 milliliter conical centrifuge tubes. People might ask, what is automated and what is not automated? Well, let's start off with what is not automated. You still have to homogenize your sample. You have to weigh your sample over into the 50 milliliter tubes. And load your sample into the sample trays, load in the cleanup of choice, load in the extract, and load in the disposable pipette tips and the other consumables such as your extraction salts and solvents. What is automated that the AutoMate Q40 does is addition of extraction solvents, spikes and standards, addition of extraction salts and buffers, sampling, sample vortexing, centrifuging, decanting, dSPE cleanup, creation of the final extract, and barcoding. The other models, what we hear is the system components, what it consists of. We sample trays, we have an XYZ robotic system, Vial Gripper, a Vial Shuttle, and an uncapping station, a pump for extraction solvents, which is a 25 milliliter syringe, and assembly for preservatives, which is a 250 microliter syringe, which is more precise for the smaller amounts of spikes you have to add in, a addition module for dosing salts and buffers, a vortex station on the deck of the AutoMate, a shaker, syncing with indexing. The indexing is key to this because we need to know which sample go which spot, and so we can keep record and don't get them mixed up. Barcode reader, we have a level determination, pipetting, and an optional fume hood that can sit on top of this system. The user interface, that's called the GUI. This is a touchscreen, cool user interface. The system basically includes these 4 buttons: methods button, a skills button, a configuration, and a diagnostics, which will give you your system tools and other things like that. Within the method, you're allowed to optimize your method. Basically, you can enter from 125 mils of solvent. You can tell it how long to mix. You can tell how long to centrifuge, and you program in the amount of supernatant you're transferring over from each step. Then you can set your spikes, and depends on which samples you want to spike. You can tell it which samples to spike. Schedule consists of the sample ID, number of samples, sample status, who's running the samples, and other ISO configurations like that. Configurations It's basically a tool that will allow you to place your pipette tips to do a solvent check, so you can check your precision and accuracy on the amount of solvent you're delivering. Then also you can have logs where it will tell you the system history, where it'll keep track of the samples that you have ran for that schedule or that day. Here is a design of the system. And if you follow the mouse and look, there is the user interface, which is a screen computer. The computer tower is hidden basically inside this drawer. Black trays are removable, so you can take these trays over to your sample prep room where you're laying out your commodity and place them in, then take them back and place them back in the system. Back here in the left corner is a sample shaker, and there are two pumps. To the right side is your salt dispensing station, cap and uncapping station. It's all right here. And all this is where your liquid gets added into your samples. Back right here where the mouse is a camera, which will take pictures of the liquid level sensing. Back corner is a 4-position centrifuge. And the robotic arm right here is an air displacement pipette. Just a system overview of the Q40. Now into the guts of the system. It's about the Vial Gripper. It's the XYZ pick-and-place robotics. The arm is calibrated to know exactly which position it's going to. The load only carries the 50 and 15 centrifuge tubes, and it's accessible to every area that it can get to on the deck. The 3-finger design to grip the top of the vial tight and pick it up and place it into the next step that needs to be performed. The vial, other than the arm, this is the heart of the system. This is where parts happen, where we can recap our 50 milliliter vials, our solvents and standard addition, and allow for solvent buffer addition. The station, the function of this is to cap and recap the 50 milliliter and 15 milliliter vials. 4-position capping alignment, so each position has its own alignment spot. We can update multiple vials from different vendors. We cap to a consistent torque so to prevent leakage. And if your vial does have condensation on it, there is no wheel slippage due to type of material that we use. Basically, how the vial is uncapped, these robotic jaws will come down and grip the top of the cap. This will slide over, apply side pressure to the vial, and spin while that cap is being held stationary, and the cap will rotate itself off. Then it's lifted up. Then the salts can be added, the solvent can be added, and the spice can be added. And then to recap it, the wheel in the opposite direction, the jaw will sit down on top of the vial, and the threads will catch, and it will cap the vial. Or is the pumper system or the extraction solvents. The unit has the ability to add up to 3 different types of solvents to a 50 milliliter tube. Typically, your solvents that you want to choose are your acetonitrile, water, and ethyl acetate if you want to do that. Variable volumes, 1 to 25 mils. Delivery system is capable at precision within 1%. The solvent flow path is chemically compatible with acetonitrile, ethyl acetate, methanol, glaciertic acid. The system will draw directly from the 4-liter vial bottles. We will not offer pH adjustment to the extraction solvent, so if you want to pH adjust your extraction solvent, you have to do that offline. In addition, this is where you can spike in your internal standards, surrogates, or QCs. Spiking range volume is anywhere from 10 to 250 microliters. I believe steps are 10, 25, 50, 75, 100, 125, all the way up to 250. This is accomplished by a pumper with a 250 microliter syringe and a multi-port valve. Accuracy and precision is within 1%. The solutions can be stored in either a 15 milliliter amber-coated vial or a 48 milliliter vial that's amber-coated also. Next step, or the next system component that we're going to talk about is the sample vortexing. The system offers a quick vortex after the addition of the solvents, so you do it with a quick vortex if needed. If not, you can bypass this step. The next step, next system is the salts and buffers. The system is capable of adding one mix salt and buffer solution, buffer mix per sample per batch. Users will purchase the pre-made reagents. They can make their own custom salt blends. These will be user adjustable. This value has changed a little bit in recent development. We can go anywhere from 3 to 9 grams now, but you program up to 5 doses. The salts will be stored in a dry environment. So basically, a 3 psi blanket of dry air is placed on top, is pumped through the system to be on top of these salts as a nice little blanket. Accuracy of delivery is plus or minus 5%. Precision of delivery is plus or minus 3%. Systems will have a quick mix station. After you add the salts, we'll cap it and get it over to the mixer right away so we can avoid the clumping issues. This is just a little design of the powder loader or dispenser. As you can see, it's a cup design. The cup design is adjustable anywhere from 9 grams. As it's in the vertical position, it is in the load, so the salt will fill the void, then it will rotate over to the dispenser position, and it will funnel the salts down into your 50 milliliter conical centrifuge tube. Making, mix time is variable, so you can mix for a minute, as short as you want, down to 30 seconds up to minutes, I believe, or maybe longer, depending on what you can mix to. Speed and efficiency of mixing will be equal or superior to handshaking. Shake speed and duration will be reproducible from sample to sample. We accommodate the multiple vial sizes, so we can do a 50 milliliter and a 15 milliliter in our shaker, as you can see in the lower right picture. Mixing low density vegetables is not a problem. Noise level is not bad. Fluency of the shaker is proven, and the vibration is isolated to the deck, so this shaker will not walk across the room on you. It's actually bolted down to the deck of the AutoMate Q40. The next step is the centrifuging. The system is capable of centrifuging 50 and 50 milliliter centrifuge tubes. To index to specific positions. So this is an indexing centrifuge, so we know exactly if we put 50 milliliter A into spot A, we need to know that we're pulling that out, so that's why indexing is key. Centrifuge is variable. Our centrifuge meets the requirements of AOSE and EN for the QueChERS method. It spins at 4,500 RPMs. It is safely contained within that box. And pipetting. The system will be capable of pipetting or decanting the extraction solvents from 2 non-miscible layers. The system will decant using a disposable pipette tips to prevent cross-contamination. So after the sample is done, transfer is done, the tip will be thrown away and will not be reused. The system can either from the 50 milliliters or 15 milliliter vials, so it transfers from all the vials on the deck. Volume ranges is anywhere from 1 to 15 mils. Our delivery and accuracy precision are within 1%. The on the deck would be the liquid level determination. System will determine the layers inside the vial to just how much liquid we have available. The system can, it'll picture, and it'll calculate the distance from the top of the food plug to the very top of the meniscus of the organic layer. And they allow us to make sure volumes are correct within our method. If in method, say, we put in 15 mils of acetonitrile into our 50 milliliter tube, that down, that food plug, we know we need at least to transfer 8 mils over to our dSPE. Well, if there's not 8 mils present, it'll flag the sample and tell us we have a volume error, and it will continue on going on with this method. So back and say, hey, did we have enough liquid for this? And it will actually tell us if it was a volume error or not, if it didn't fall within our parameter. The camera is also capable of reading barcodes. As you can see, it does do both 50 and 15 milliliters taken in the picture. On the left side picture, top left, is a picture of a organic layer and an oil layer that's very clear, so we can determine, so we can see two very clear substances. Then on the right, you can see that's actually a commodity placed inside the vial. I believe it's an apple sample, so you can see it measures from the top part of the apple sample food pull up to the top layer of the meniscus. And it also does the same thing for the dSPE cleanup. You can see it'll measure the top layer of the dSPE cleanup to the top layer of the meniscus, and it'll calculate that volume, so we have enough volume to transfer over to our next steps. Piping is use conductive pipette tips. So when we use these conductive pipette tips, we can able to sense the top part of the liquid layer. As I said before, the volume ranges anywhere from 1 to 15 mils. Delivery and accuracy and precision are within 1%. Each tip is thrown away after each sample, so it prevents cross-contamination. With the QueChERS platform, you have an option to cleanup or no cleanup. If you decide not to do the cleanup, you select that within your method. It'll bypass the cleanup step and just transfer the supernatant from your liquid extraction part over your final vial, and it's ready for analysis. But if you decide to do a cleanup, this is AutoMate the dSPE cleanup steps using commercially available 15 milliliter dSPE tubes from multiple vendors such as Agilent, UCT, Restech, Water, Sigma, Phenomenex. So there are different types of flavors out there. We can do the cleanups of the 15 mil vial. You match the dSPE cleanup vials to the sample matrix. Volumes are determined by the method. So depending on which method you're running, you might transfer over 8, you might transfer over 6 mils. So it depends on the EN or the OAC. Or, as I said before, the user can create a method and skip this step if you don't need a cleanup. Extracts are basically empty 15 milliliter conical centrifuge tubes that are into the third row into the sample tray. Precision can be added to this vial, anywhere from 10 to 250 microliters. The cleanup process is done after it's spun down. Basically, we'll use the robotic arm and the air displacement pipette with a clean tip and transfer over the final aliquot, the final extract vial. And then thus it is ready for analysis on either the LC or GC triple. The experiment that we just recently performed here at Teledyne Tekmar was we ended up creating a grid method for us to run. So the choice that we chose was oats. We oats back in-house. We milled down to a powder. Used the automated extraction, which is the AutoMate Q40. We did a modified unbuffered method. Sub-list of target pesticides. We followed normal QC guidelines, and then we got our analytical results. The instrumental conditions, the MS or the LC triple performed using the Synergy 4 Fusion RP 80 angstroms 50 by 200 by 50 by 2 millimeter HPLC column. Phenomenex column was placed into the Shimatsu NextEra LC system, and is interfaced with a ABX QTrap 4500 spectrometer. This is the extraction technique that we use for the AutoMate Q40. Basically, we weighed out 3.5 grams of the ground up oats and placed it into the 50 milliliter centrifuge tube. Centering oats, you have to let the swell. We get 10 milliliters of water offline and let them swell for 20 minutes. After that 20 minutes was done, we placed the samples into the AutoMate Q40. We had 50 microliters of internal standard, which is TP, and TP solution, and QC spike solution if necessary. 10 milliliters of straight acetonitrile. For this extraction, we chose to do 5 grams of unbuffered nitrous extraction salts, which is magnesium sulfate and NaCl. After we're added, we capped and shaked vigorously for 5 minutes. We centrifuged for 5 minutes. Centrifugation was done. We transferred over 8 milliliters of the supernatant over to a AOSC TE tube that contained magnesium sulfate, PA, and Decanting. After the supernatant was done, the tube was capped, showed a minute, and centrifuged for a minute. After centrifuging, the final extract was transferred over into the final extract tube, and then it was transferred to the auto sampler vial and analyzed by the LC triple. First, I believe we did a 10x dilution. So we took 900 microliters of mobile phase A and 100 microliters of our X and did the dilution, and they're ready to run for the LC analysis. For LC MSMS conditions, as you see, our curtain gas was at 30, ion spray voltage was at 5500, force temp was at 400, our collision gas was a medium. Down below is a subtarget list of pesticides. As you can see, it's a wide range of classes. Their corresponding retention times, the precursor ion, and the first quantization ion, and the confirmation ion. The dSPE and CXP that are listed here are first for the want ion. For our LC side, our LC parameters, as I said before, we use the Synergy 4U Fusion RP angstrom column. Dimensions were a 50 by 2. Our phase that we determined to be optimal was a 5 millimolar ammonium formate and H2O, and 5 millimolar ammonium formate and methanol for B. Decided not to pH adjust this because the pKs of the compounds were pretty much close together, so we didn't really need to do a pH adjustment for this, for our mobile phase. We ended up starting off with a 20% organic, working our way up to 100% organic at 9 minutes. We held it there for 1 minute. Then we adjusted back down to 20% organic. Then to flush the column out for about 3 minutes, and then we started at 13.1 minutes. So our runtime was 13 minutes. Our flow rate was at 300 a minute. Our DC column our LC column temp was 30. Here, this is a scheduled MRM chromatogram for our ABX 4500 QTrap. You can see we got great recoveries for our pesticide. I leave this a 50 ppb sample. About the results, as you see, our linearity Anything was 0.998 or better. Our spikes, we do a 20 ppb low spike and a 100 ppb high spike. As you can see, all the percent recoveries and percent RSDs fall within the guidelines set forth by AOAC. So we can go anywhere from 70 to 120% for our recoveries, and our RSDs have to be below 20%. As you can see, all of our RSDs are 20%, and all of our recoveries do fall within the allotted range of 70 to 120. On conclusion, all pesticides gave outstanding recoveries and showed excellent precision. Our risks, as I said before, ranged anywhere from 79.4 to 110% for low and high spikes. Our precision ranged anywhere from 1.4 to 14.3% RSD. Using the AutoMate, it enables a reliable and more reproducible extraction. This allows significant time and labor savings for your lab. Give you a little insight about how many samples the AutoMate Q40 can do within a day. You come in the morning, you load up 40. As running throughout the day, you set pauses that will stop the system after 10 samples have been complete, 20 samples have been complete, 30 samples have been complete, and you can replace the completed trace with new samples so you can continue wrapping around. You've got 80 samples done in a day in this process. So when you come in the morning and load up 40, by the time you leave after your 8-hour shift, the next 40 will be running. So you'll have 80 samples be prepared in a day. And I'd like to thank you guys for attending the webinar that we put on today, and I'll be around to answer any questions that you guys might have for me or questions about the product. We have a question saying, how does the system handle the waste? There's not really much waste that's the system. It does say in our how we deliver our solvent is there might be a waste sample, so it'll dispense it into a glass waste jug that is located on the back of the instrument within the solvent pan, and just take that waste and dispose of it the correct way as